This video recording is for example 8.7 of lecture 8. In this example, we are given a spring that is stretched 10 centimeter by a force of 3 newtons. So basically, it talks about the property of the spring. And then given the new mass that is hung from the spring and is also attached to a viscous damper that exerts a force of 3 newtons when the velocity of the mass is 5 meters per second. Additionally, it is subjected to an external force, which is 3 cosine 2t. If the mass is pulled down 5 centimeters below its equilibrium position and given an initial downward velocity of 10 centimeters per second, we are asked to determine its position y at any time t. Use g is equal to 9.8 meters per second. So similar to 8.5 and 8.6, i-summarize muna natin yung mga given sa problem na to. And ang difference lang, 8.7 is mas familiar tayo sa units niya, SI. So we just have to make sure consistent tayo. Ang force natin should be newtons. Ang time is in seconds, mass is in kilograms, and then velocity is in meters per second. Length is in meters. So let's start, no? Per statement, let's see kung ano yung makukuha natin sa kanya. So una, it describes the nature of deformation of the spring. So mag-apply ka ng 3 Newton, magkakaroon ka ng additional deformation of 10 centimeters. So technically, this is your Hooke's law. So from Hooke's law, F is equal to Kx. So in this case, we have 3 Newton force is equal to K times X is basically 0.1 meter. So K in this case is equal to 30 Newton per meter. Then mass is equal to 2 kilograms. And then viscous damper. So instead of C, ang given sa atin ay damping force and velocity. But we know that the damping force is proportional to the velocity of the block. So here, we have 3 newtons then is equal to C times 5. So it follows that C is equal to 0.5 Newton per meter per second, or Newton second per meter. Then the forcing function is given 3 cosine 2t. We are asked, or we are also given yung initial condition. So sanay na kayo dito, downwards ulit, so positive 5 centimeters or 0.05. And then from the equilibrium position yun. And then the velocity, y prime at 0 is equal to downward then, so positive 0.10 meters per second. So this one is in meters. So our ODE, or our initial value problem, will be m y double prime plus c y prime. Sorry, it should be 0.6. 0.6 to 0.6. So this is 0.6. So 0.6 y prime plus k, which is 30, y is equal to 3 cosine 2t. So very clear naman, we are under the damp vibration na case kasi meron ng C. So for the complementary solution, we just have to check yung nature of damping. If we recall, meron tayong 3 cases: critically damped, overdamped, then underdamped. Tapos based on the classification, meron na tayong specific solution for the complementary solution. So we will do that. So we categorize the ODE. Okay, so sabi natin, damp vibration ito, pero specifically, we have to determine kung anong klase ng damping. Okay, so we just have to compare the critical damping ratio and the given damping coefficient. Or in this case, yung sinolve natin. Yung damping coefficient natin is 0.6. Yung critical is square root of 4mk. Okay, madali naman itong i-derive from the discriminant of the characteristic equation. So we have square root of 4 times 30 times, that's 4k, sorry, and times 2. So we have square root of 240, which is, we can just say 4 square root of 15 Newton per meter per second. So in this case, very obvious, sobrang liit ng ating damping ratio compared to the critical damping. So we conclude that the system is underdamped. So we go back to the lecture kasi yung sinasabi ko nga, yung complementary solution nito will be dependent on the type of damping. So if we do that, so, ito yung sinasabi natin, no, yung particular solution, yun yung related sa transient component, and then yung steady state component, yung particular solution. So, we go back to the underdamped system para makuha natin yung solution. So, ito yon, no? U of t is equal to e raised to negative c over 2mt times a cosine t times the square root of omega squared minus c over 2m squared plus b sine t square root of omega squared minus c over 2m squared. So again, to confirm lang, yung given sa atin na damping coefficient is less than the critical damping ratio. So going back to our whiteboard, okay, so yung solution for the underdamped system based on lecture 8 is given by, so in this case, YC na siya, e raised to negative c over 2m times t multiplied by a cosine, tawagin na lang natin siya, ano ba? PT plus b sine pt. What is p? Ito yung i-compute natin. Ito yung square root ng omega squared minus c over 2m squared, which is kaya na natin itong ma-derive, no, from the given. So una, what is c over 2m? So that will be 0.6 divided by 2 times m, which is 2. So we have 0.6 over 4. So that's 3 over 20, or 0. So that's 3 over 20, or 0.15. Then what is P? Okay, we need the natural frequency omega. So yung omega, we can compute, that's square root of k over m. So that's square root of 15. So that's square root of 15 squared minus c over 2m, that's 0.15 squared. So yung value ng p natin will be 15 minus 0.15 squared. And then take the square root of that. We have approximately 3.87. Okay, so therefore, yung YC natin will just be equal to e raised to negative 0.15, sorry, 0.15t times a cosine 3.87t plus b sine 3.87t. So, example lang, ayaw niyong bumalik dun sa lecture and or nakalimutan niyo yung concept ng underdamped, tapos meron palang derived formula, ano yung alternative na pwede natin gawin? So, of course, ODE naman ito, so we can always solve that using the principle of lecture 6 and 7. So, for instance, an alternative solution for YC. So we go back to the ODE. So we have 2y double prime plus 0.6 y prime plus 30y is equal to 0 muna kasi y is yung kinocompute. So your characteristic, or pwede mo i-simplify para maging standard form, y double prime plus 0.3y prime plus 15y is equal to 0. So your characteristic polynomial or characteristic equation is lambda squared plus 0.3 lambda plus 15 is equal to 0. And then we get the roots using the quadratic formula. So lambda will be equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So here, lalabas yung ating lambda will be, so as expected, imaginary yung lambda natin. Kaya magkakaroon tayo ng sine and cosine. So we have, well, that's negative 0.3 over 2. So that's negative 0.15. And then plus or minus, estimate na lang natin, 3.87 I. Okay? So, based on this, yung nature of roots, ang magiging solution natin ay e raised to negative 0.15t times a cosine 3.87t plus b sine 3.87t. So, diba? As you can see, same lang yung nakuha nating solution. Kasi nga, lahat naman yan, ang basis ay second order ODE. So, regardless of whether you take or you take YC from the concept of spring mass or from the concept of a generic ODE, you will be getting the same YC. So now, let us solve or let us set up or establish the methodology to compute for YP. So dito, dalawa din yung solution natin kasi going back, so here kasi we have, going back to the problem, yung ating forcing function is in terms of cosine. So unlike 8.5 and 8.6, baka this time, pwede nating magamit yung derived formula for shown in lecture 8. So tingnan natin. Okay, so here, yung generic differential equation where the solution was derived is already in terms of cosine. So, madali, applicable itong particular solution na to. Pero kung kamukha na naman na naging sine na naman yung problem natin, edi hindi natin ito magagamit, then we have to use MUC for the particular solution. Okay? So, medyo mahaba lang yung formula natin. But as an exercise, we can verify kung parehas yung lalabas, kung mag-MUC lang tayo. Okay, so in this case, medyo mahaba-haba yung YP. Dalawa yung form niya. I mean, dalawa yung term. We have F0 over M times the natural frequency squared minus the frequency of the external force, capital omega squared, times omega squared minus plus C omega M squared. That's cosine omega t. And then plus F0 over M times C omega. So, meron palang squared dito. Tapos dito, F0 M squared C omega, capital omega, divided by omega squared minus capital omega squared squared plus C capital omega over M squared sine capital omega. So para madali, let us just compute yung mga terms. So F0, recall lang natin, F0, ito yung amplitude ng forcing function. So that is 3. And then M is equal to 2. Then the natural frequency of the spring mass system is square root of 15. The frequency of the oscillating function is 2. Yes. Okay, so yung omega squared minus omega squared will be 15 minus 4, 11 yun. Yung C over M ay, yung C natin ay 0.6. So 0.6 times 2 over 2, we have 0.6. So yung nasa denominator, lagay ko lang dito, denominator. Ito, basically yan. Mag-a-appear kasi siya dun sa both terms. We have 11 squared plus 0.6 squared. So that's 121.36. Okay, so yung YP natin will be F0 over M. So that's 1.5 times 11. So 1.5 times 11, so that's 16.5 divided by 121.36. Diba, mabilis lang. Cosine, capital omega is 2t, and then plus F0 over M squared. So we have 3 over 4 times C, which is 0.6, times capital omega, which is 2. So we have 9 over 10, 0.9, divided by 121.36 sine 2t. So simplify natin with proper significant figures. No? 16.5 divided by 121.36, That's around 0.136 cosine 2t. And then plus 0.9 divided by 121.36, that's 0.00742 sine 2t. So, ito yung ating YP. So, let's apply, no? Bago natin i-solve yung A and B, let us apply yung generic na MUC para i-confirm kung tama ito yung YC and YP natin. So, technically, nagawa na natin siya dito. So, yung YP na lang. Okay? So, an alternative solution to YP. So, in this case, yung right side ng equation natin is basically yung f of t, which is 3 cosine 2t. So, alam na natin yung finite family of functions, which is composed of cosine 2t and sine 2t. So, your YP trial is A or C cosine 2t plus d sine 2t. So, ngayon, sure na tayong walang duplication kasi ang solution natin ay exponential times cosine and sine. So, it follows kahit same sila ng frequency, omega and small omega and capital omega, sure pa rin tayong walang duplication kasi nga may damping na. Yung duplication between YC and YP, nangyayari lang yon dun sa no damping case. Yung example, 8.5 and 8.6. So here, we can set up yung YP prime. We have negative 2 sine 2t plus 2d cosine 2t. And then YP double prime will be equal to negative 4 cosine 2t. Sorry, nawala na yung c, no? So, 4c. And then minus 4d, sine 2t. And then we substitute to the ODE. Yung ODE natin kasi is 2y prime plus 0.6 y prime plus 30y is equal to 3 cosine 2t. Okay, so we have 2 times negative 4c cosine 2t minus 4d sine 2t, and then plus 0.6 times y prime negative 2c sine 2t plus 2d cosine 2t, and then plus 30 times c cosine 2t plus d sine 2t. Dapat equal daw yan sa 3 cosine 2t. Then after that, we just solve for c and d by comparing like terms. So for cosine 2t, we have negative 2 times 4c, so that's negative 8c. Then here we have negative 1.2, sorry, negative 1.2d, and then plus 30c is equal to 3. And then for sine 2t, we have negative 8d. This one is positive pala. Negative 8d minus 1.2c, and then plus 30d is equal to 0. So, we have a system of equation. Pwede kayong matrix. Pwede rin naman yung usual natin na process sa pag-compute ng solution. We have 22c plus 1.2d is equal to 3. And then we also have negative 1.2c plus 22d is equal to 0. And then we will be able to solve for C and D. So let's do that. 22, 1.2, 3, negative 1.2, 22, and then 0. So yung C natin ay 0.136. Yung D natin ay 0.00742. So, our YC is 0.136 cosine 2t plus 0.00742 sine 2t. So, as you can see, parehas yung nakuha nating solution. Sorry, it should be YP pala. Yan. And then, after this, di pa pala tapos, no? After this, isosolve na natin yung arbitrary constants dun sa complementary solution. So, we know that y is equal to yc plus yp. So, y equals, ang yc natin, e raised to negative 0.15t times a cosine 3.87t plus b sine 3.87t and then plus yc, which is 0.136 cosine 2t and then plus 0.00742 sine 2t. So medyo mahaba-haba ito. Ang initial condition natin, y at 0 is 0.05. So 5 centimeters below the equilibrium position. So we have 0.05 is equal to e raised to 0 is 1 times a cosine 0 is 1. Yung b times sine 0 is 0. And then plus 0.136 kasi cosine 0 is 1. Then 0 na to. To be able to solve for a, which is 0.05 minus 0.136. So negative 0.086. And then for b, kailangan natin yung y prime. So y prime is product rule, negative e 0.15t times negative 3.87a sine 3.87t. Sorry, yeah, correct. Plus 3.87b cosine 3.87t. Then plus, ito naman, derivative niya, negative 0.15 e raised to negative 0.15t. And then a cosine 3.87t plus b sine 3.87t. And then ito naman, derivative niyan will be negative 0.136 times 2 sine 2t plus 0.00742 times 2 cosine 2t. And based on the problem, y prime at 0 is equal to 0.10. So in this case, 0.10 is equal to, ito muna, e raised to 0 is 1. So we have, ito lang yung magkakaroon ng value, 3.87b. And then here, e raised to 0 is also 1, pero meron ka negative 0.15 times, ito lang magkaka-value, times a. And then here, ang may value lang is ito. Plus, times 2 mo yan. So we have 0.00742 times 2, that's 0.01484. So alam natin yung A, substitute natin doon. Alam natin na negative 0.086 yan. So masasolve natin dito yung B. We have 0.10, lipat sa kabila, positive kasi ito. So minus 0.15 times 0.086 minus 0.01484 divided by 3.87. So you have 0.0186. Or 187. So isa pa. To confirm. Excuse. Check ulit natin. 0.10 minus 0.15 times 0.086 minus 0.01484. So, minus 0.01484. Yeah. So, I think confirmed naman. So, our solution now becomes y of t is equal to e raised to negative 0.15t times negative 0.0860 cosine 3.87t plus b 0.0187 sine 3.87t plus 0.136 cosine 2t plus 0.00742 sine 2t. Yan. So, ito na yung ating final solution. So, again, para mas ma-interpret natin yan ng mabuti, we can plot the function or provide specific values of t para meron tayong idea kung nasaan yung block natin at any time t with respect to the equilibrium position.